Library, and we're going to talk about something that everybody always likes to talk about, weather, but also a possible connection with astronomy. Is it possible that perhaps we could use something other than the regular forecast maps that are put out by the National Weather Service to forecast the weather? Can we use the moon, the sun, the planets to make long range weather projections? And so this talk tonight deals with the science, or maybe it's the pseudoscience of astrometeorology. And we're going to be talking about that this evening. What I'm going to do is I'm going to share my screen here so that all of you will be able to see what I see on the screen. And I'm going to start my slideshow right now from the beginning. Now, can all of you see that? Can you see that, Katie?
Yeah, you're good.
That wonderful logo, the Scarsdale Public Library. Again, thank you on behalf of the Scarsdale Library, all of you who are on Zoom right now attending our talk tonight. Okay, I'm going to start off with this. Now, this is if you're into astronomy, if you're an amateur sky watcher or an amateur observer, you need to have this in your library each year. This is an annual publication. It's called the Observer's Handbook. It is put out by the Royal Astronomical Society of Canada. And inside of this handbook, you have everything that is going to take place in the sky for the upcoming year. All of the phases of the moon. Are there any meteor showers of note? When can we see Venus pass close to the moon, a conjunction as it's called? When can we see a conjunction between two planets? Are there any comets that are due in 2021? All of these things and many, many other things are covered in this handbook, the Observer's Handbook. The thing that is interesting about this book is that they give you specific times. When will the eclipse of the moon happen? On November 19th. When will it begin? They'll give you to the minute when that event is going to take place. What time will the sun set on July 15th? When will the moon rise on May 31st? All of these things, and they are to the minute, and they are accurate. Everything in this book is absolutely, well, it's absolute. There is no, well, maybe the moon might rise, or maybe we might get an eclipse, or the possible. None of that. Everything in this book is that is mentioned in this book is going to happen. Wouldn't it be wonderful if we had a similar handbook, a similar publication that could tell us what the weather is going to be like on Memorial Day, or the 4th of July, or Labor Day, or Christmas, or your birthday, or maybe your graduation day? Wouldn't it be wonderful to know what the weather is going to be like on that? Well, wait a minute. We do have actually a couple of books that do that, and you could probably find them in bookstores across the area. The almanacs. There is the Old Farmer's Almanac, and there's also the Farmer's Almanac. Now, the Farmer's Almanac, as you see there at the bottom, the orange book, they've been around since 1818. And then there's the Old Farmer's Almanac. They have been publishing their weather predictions and other interesting facts since 1792. That's why they are the Old Farmer's Almanac as opposed to the regular. But these two books have within their pages weather forecasts that tell you supposedly what the weather is going to be like on specific days during the course of the year. And so I guess if you want to know what it's going to be like on the 4th of July, or on your birthday, or on some holiday, you buy the book, you thumb through it, you look for the weather forecast, and hopefully the weather will turn out to be what the almanac is predicting. Interestingly, and I've looked at both almanacs, and let's say, you look at the weather for the 4th of July, the one almanac might say one thing, the other might say the other, and yet they both claim that they have accuracies up to 80%, which I guess is pretty darn good. I mean, the weather casters that you see at night or listen to on the radio, they have, very, very good batting averages. When I used to do the weather on News 12, I always tried to do my best to be 100% accurate. Sometimes that didn't turn out the way I wanted it to, but usually 9 times out of 10, the weather was the way we had forecasted or predicted. And in these almanacs, they claim 80% accuracy, although others have said, no, it's more like a coin toss. So how do they do it? That is a good question. Both almanacs claim that they use a secret formula that they did not want to divulge to the general public, because if they did, well, then everybody would be using that formula to make weather forecasts for themselves. But how do they make a weather? How do you make a weather forecast? You know, the Farmer's Almanac for 2021 probably started to get put together, the forecast and all the information, a year or two in advance. How do you make a weather forecast 1 or 2 years in advance? Well, there are ways, I suppose. One way would be perhaps the moon, the phases of the moon. Maybe somehow looking up in the sky at night, you see the moon changing its shape and its phase, and maybe somehow or other that might have something to do with the change of the weather. Well, a while ago, I think it was about 20 years ago, one of the science magazines, I think it was Sky and Telescope, somebody wrote into Sky and Telescope magazine, astronomy magazine, and said, we have discovered by going back over many, many years, we found a document which we believe is the so-called secret formula that the Farmer's Almanac or the old Farmer's Almanac uses to predict the weather. And apparently it does indeed deal with the change of the moon. As you see at the top there, it says, this table is the result of many years' actual observations and shows what probably would be the weather following the moon's entrance into any one of its quarters. First quarter, full moon, last quarter, new moon. And so you use this chart to determine first when the moon does enter that particular phase. Let's say the first quarter moon was going to occur between 4 and 6 a.m. In the summertime, what does that mean? According to this chart, it would mean rain. And also in the winter, it would mean rain. Who created this? This was created more than 160 years ago by a Dr. Herschel for the Boston Courier. And it first appeared in the Old Farmer's Almanac in 1834. Now, the editor of the Farmer's Almanac, the Old Farmer's Almanac, wrote, while the data in this table are taken into consideration in the year-long compiling of the annual long-range weather forecast for the Old Farmer's Almanac, they rely more on their projections of solar activity. In other words, the Old Farmer's Almanac says, yeah, this is interesting, you know, using the moon, but we rely more on the solar activity, solar flares, sunspots, occurrences on the sun. We'll investigate that in a little bit. Here's an old limerick about using the moon. The moon and the weather may change together, but change of the moon does not change the weather. If we'd have no moon at all, and that may seem strange, we'd still enjoy weather that's subject to change. Well, maybe, maybe not. I do want to point out this gentleman, and he probably is not familiar to any of you unless you have been into weather, into meteorology for a very long time. He was actually a TV personality here in the New York metropolitan area for all of 1 year in 1966. His name is Harry Geiss, and Harry Geiss came to WCBS Channel 2 from California, from the West Coast. You see, before 1966, the weather on Channel 2 was done by a young lady by the name of Carol Reed. And Carol Reed became a very popular face and was very familiar here in the New York area. She did her weather forecast. And then when the weather forecast was over, she would look in the calendar, smile, and say, and don't forget, have a happy. She was very popular, as I said, through the 1950s and 60s. But then a competitor of Channel 2, Channel 4, ended up with a gentleman who started doing their weather, a gentleman who some of you may remember, Dr. Frank Field, a real meteorologist, a real scientist. And Channel 2 said, well, if they can get somebody who's a real scientist, then we got to get somebody who's a real scientist. So they said farewell to Carol Reed, and they brought over from their affiliate in California, Harry Geiss. Now, Harry Geiss was an interesting character. Not only did he do the weather or forecast the weather for, the next few days, Harry Geiss claimed to be a long-range weather expert. And during the Columbus Day weekend in 1966 on WCBS Channel 2 in New York, he said, "I have a special announcement to make. I am going to make a prediction," said Harry Geiss. "We are going to have a white Christmas. I am predicting a big snowstorm that's going to hit us either on Christmas Day or possibly Christmas Eve, and it will dump a lot of snow on the New York metropolitan area. It will be the first white Christmas in New York for many years, and I am predicting that tonight on this Columbus Day holiday." And you see something like that, and you say to yourself, probably, "What, is this guy crazy? How can he say something like that? How absurd is that? That he would actually go sticking his neck out that far, 2 months in advance or more, to forecast a big snowstorm?" And every time we got to a holiday, when we got to Veterans Day, he would say, "And don't forget, we're calling for a white Christmas this year." You get to Thanksgiving, "Oh, this is a big, wonderful family holiday, but the biggest holiday of all, Christmas, we're going to have a lot of snow." He kept reminding people, and what happened? Well, guess what? Guess what happened? There was a snowstorm that hit between December 23rd and December 26th. And you see here on this particular map, uh, the areas that are in light blue saw as much as 10 to 20 inches of snow. In the dark shades of blue, as much as 20 inches of snow or more. In the New York metropolitan area, that's where Channel 2 was focused on for the most part. In New York City, Long Island, northeastern New Jersey, 4 to 10 inches of snow. The snow started, I remember this, I was a very young boy, and the snow started on the afternoon of Saturday, December 24th, continued all through the night. There was even thunder and lightning. It's known in the New York weather annals, in fact, because of that lightning and thunder, as the Donner and Blitzen snowstorm. But the bottom line of it is that that prediction by Harry Geiss was absolutely true. Made the front page of the New York Times on Christmas Day. "Snow brings city white Christmas. Travel snarled. Ice and poor visibility do not deter the crowds of last-minute shoppers, but there was an emergency declared. Sanding and snow removal equipment rushed out. Airlines delayed." Everything that Harry Geiss had suggested back in October came to light. In the aftermath of the storm, people said, "Harry, how did you do it? What did you, what's possible?" And all Harry Geiss would say was, "I used some well-known cycles of the sun and of the moon." Well, the moon does have some interesting cycles. For example, there is the Metonic Cycle. The Metonic Cycle was named after a Greek who lived around 500 BC. That's what? That's 2,500 years ago. And yet this Greek, Meton, discovered a very interesting fact, that over a period of 19 years, we call that 235 lunar months. A lunar month is equivalent to 29 and a half days. And after 235 lunar months, or 19 years, the new and full moons will return to the same days of the year. For example, everybody was making much ado on Monday of the super pink full moon, right? Remember that? Hard to forget anything like that. That was on the 25th of April of this month. Well, you know what? There was a full pink moon back in 2002, I should say, 19 years ago, on the same date, April the 25th. And you know what? If you add 19 years to 2021, in the year 2040, on April 25th, we're going to have another full pink moon on the same date. And Meton discovered that 19-year cycle 2,500 years ago. It was the basis of the ancient Greek calendar and is still used for calculating movable feasts such as Easter. Well, if that be the case, is it possible that maybe Harry Geiss looked at the lunar phase and determined that there was a big storm, a big winter storm, 19 years earlier in 1947? Remember, this snowstorm on Christmas hit in 1966. So 1966, you subtract 19 from that, that's 1947. Was there any kind of major storm around Christmas time in 1947? Whoa, whoa, yes. On the day of Christmas into the next day, the day after Christmas, a record 25 inches of snow crippled New York City and Long Island. All traffic slowed. Long Island is disrupted. Thousands maroon. Fuel ample. Food is ample. Fuel is short. Well, obviously, that's what Harry Geiss used. He used the moon. He used the 19-year cycle. Oh, wait a minute. Hold on. Is it really that easy? If it was, all we'd have to do is look at the weather on a certain date and then say, okay, this is what was the weather on that date 19 years ago, and then we move it forward 19 years and say that's what we're going to have this year. It doesn't work out that way. No, it doesn't. So maybe it's not just the moon's cycle, the phases that help to predict the weather. Maybe Harry Geiss used something else. What else is there that involves the moon? Well, there involves distance. You know, the moon does not go around the Earth in a perfect circle. If it did, it would be the same distance away all through the cycle during the course of the month. We know on average that the moon is 238,857 miles from the Earth. But again, that's an average. Sometimes the moon is closer than that. Sometimes the moon is farther away from that. And you could see the difference between these two moons. The moon that you see on the left was the full moon that occurred at apogee. That's the point in the orbit of the moon which places it farthest from the Earth, 252,000 miles away. The moon image that you see on the right, noticeably larger, was taken when the full moon was at perigee, its closest point to the Earth, 221,463 miles away. The size of the moon differs by about 13%. And also because when the moon is closer to us than when it's at apogee, it appears not only larger, but a bit brighter. The moon at perigee appears on average about 30% brighter than when the moon is at perigee, when the moon is at apogee, I should say, farthest away from the Earth. This moon on the right in recent years has had a very popular name attached to it, the super moon. Well, you know, it's not all that much bigger really than the moon when it's at its farthest point. In fact, my boss at the Hayden Planetarium, Dr. Neil Tyson, ridicules that term supermoon. He said the supermoon is only 13% larger than when the moon is farthest away from the Earth. I mean, if you made a pizza that's normally 15 inches wide and you increase the diameter of the pizza by half an inch, would you call that 15.5-inch pizza a super pizza? But the mainstream media loves to brand things, and they brand the moon when it's closest to the Earth as the super moon. Well, when the moon is very close, closer than average, does it have a say in our weather? Might it have a say in our weather? This gentleman that you see on your screen now was fairly certain that it did have some sort of influence on the weather. His name is Stephen Martin Saxby. He lived in England, and he studied lunar and astronomical tables. And in 1868, he discovered that in October of 1869, the moon was going to be at new phase. That's the phase when it's in line with the sun, so we can't see it. But it was also going to be at the same close distance, perigee, 221,000 miles away from the Earth, its closest point to the Earth, and also at the same time that was happening, that the moon would be located or would be visible overhead directly from the equator. And according to Mr. Saxby, this was going to cause a dramatic storm to occur. This storm would be one that would bring tremendous waves and also storm surge and also strong winds. Oh, and he wrote this article up for one of the local newspapers in London, making this projection. I think it was October the 4th of 1869. He said, watch out, because on that day, we're going to have a major, major storm due to the occurrence of the new moon coinciding with perigee passing over the equator at the same time. Those three events will lead to a major storm. Well, this article that Mr. Saxby wrote caused a lot of concern in the UK, in the United Kingdom, in England. And obviously, the question that everybody was asking was, where? Where will this storm take shape? Where will this storm occur? Will the United Kingdom be in its crosshairs? Would we see a major storm here? What are you talking about? Where is this going to take place? And Mr. Saxby wrote a letter in response to all of these questions. And here is his response to that. He says, quote, "The warnings apply to all parts of the world. Effects may be felt more in some places than in others. It's painful to have to forebode evil, but better than thus to merit self-reproach under circumstances which might lead to permanent regrets. Could I save just one life, it would be very cheaply purchased in making better known certain laws of nature." In other words, I don't know where the storm is going to appear. It's going to appear, but I have no clue where it's going to be. It could be anywhere. And of course, you say to yourself, what the heck kind of a prediction is this? And it really is true. On any given day, today, for example, maybe not here in the New York metropolitan area, but maybe in some other part of the world, I can assure you there's some kind of a major atmospheric hemorrhage going around that's causing a lot of wind, a lot of rain or snow, or a lot of precipitation, and a lot of problems if it occurs out at sea. Mr. Saxby was just simply saying, well, this warning applies to everybody, to all parts of the world. In essence, this was kind of a meaningless prediction or projection. We know, for example, that when the moon is at new or full phase, the tides always run a bit higher than normal. We call that an astronomically high tide. And when it's near the time when it's at closest point to the Earth, the tides are generally 30 or 40% higher than they would if the moon wasn't so close. Now, I said this was a useless or a meaningless prediction, but there was one gentleman who took this prediction to heart. His name was Frederick Allison, and he used to write a column in a newspaper in the province of Nova Scotia. It was a popular weather column, and usually in most cases, it talked about the weather that had just occurred over the last week or so. But in his column for the beginning of October, remembering or hearing about Saxby's claim that there was going to be a major disturbance, a major system that would cause lots of turbulence in the atmosphere, Mr. Allison took it upon himself to make a projection. He said that there would be a major storm that was going to hit, coinciding with that new moon, coinciding with that perigee occurrence when the moon was closest to the Earth, when it was also passing over the equator. And he mentioned that in his newspaper column in Nova Scotia. And here is what he wrote. Woo! I believe that a heavy gale will be encountered here on Tuesday next, the 5th of October, beginning perhaps on Monday night, possibly deferred as late as this Tuesday night. But between those two periods, it seems inevitable. Roughly speaking, the warmer it may be on the 4th, the more violent will be the succeeding storm. Apart from the theory of the moon's attraction as applied to meteorology. Now, in this case, when he said that, he's making a direct reference to what Saxby was saying in England. Apart from the theory of the moon's attraction as applied to meteorology, which is disbelief by many. In other words, he's saying a lot of people don't believe Saxby because it seems like hogwash. But in spite of all of that, he said the experience of any careful observer teaches him to look for a storm at the next new moon. And this appeared in the Halifax Evening Express, October 1st, 1869. Now, he's forecasting for October the 5th. You say, well, what's the big deal? You know, we have in today's day and age, we have 7-day forecasts on TV. Some TV stations even forecast out to 10 days. So what's the big deal about forecasting, 3, 4, 5 days out? Well, the thing is that back in 1869, they didn't have radar. They didn't have satellite photos. So we really didn't know. We really couldn't tell what was lurking out there a few days down the road. And here, simply taking the word of Mr. Saxby in England, Mr. Allison decided that, hey, this could mean us. Why don't I put it in the newspaper, my column, and if something happens, maybe I might make a name for myself. Well, guess what? Guess what? When that paper or that prediction was published in the Nova Scotia newspaper, there was a tropical cyclone, a hurricane that at the time was located off the southeast coastline of the United States on the 1st of October. And on the 2nd of October, it made headway to the north and northeast. Then came the 3rd, the 4th, and the 5th. And Nova Scotia, while it did not get a direct hit from the storm, was located in what we call the right rear quadrant of the hurricane or tropical cyclone. The absolute worst place to be is if you are to the right of the track of a tropical system. Guess what? New York was to the right of a tropical system by the name of Sandy back in 2012, and you saw the damage that that storm wrought upon us, even though New York was not in the direct path of the storm. And I must tell you that this storm, and they didn't have names back then in 1869, though making landfall along the coastline of Maine, caused quite a bit of damage across not only Maine, but New Brunswick, Prince Edward Island, Nova Scotia. It came true. What Mr. Allison had projected in his newspaper article, it came absolutely true. There was terrible damage, tremendous rains, floods, homes were washed out, tremendous winds, all kinds of major turbulence due to that storm. But you want to know what? Even though Frederick Allison had predicted that in his newspaper column, he never really got credit for much of anything. Everybody suddenly remembered the projections or predictions by Saxby. And to this day, if you go on Wikipedia or go online, next time you're online on your computer, or Google Saxby's gale or Saxby storm, you'll be able to read about this particular storm, all accredited to Saxby. Yet Saxby didn't predict where the storm was going to take place. He didn't say it was going to hit Nova Scotia. Allison did. But Allison is forgotten in history, all but forgotten. Everybody remembers the name of Stephen Martin Saxby. Well, I found this interesting. So interesting, in fact, that in October of 2002, I wrote a feature article for WeatherWise magazine. Now, WeatherWise is read by meteorologists, amateur and professional meteorologists, not only in the United States, but around the world. It's a very popular journal. And my article said, is it lunacy to think that Saxby's gale could recur this October? Because 133 years after the fact, guess what? The moon was going to be new on October 5th. Guess what? The moon was going to be at Perigre, closest to the Earth, on October 5th. Guess what? The moon was going to be passing directly over the equator on October 5th. All of the events that occurred 133 years ago with Saxby's gale, apparently, in an astronomical sense, was going to happen again in 2002. And so my article simply brought back the historical parameters of what Stephen Martin Saxby wrote about. And I mentioned Mr. Allison as well. And I simply asked in this article, is it possible that we might see a recurrence of Saxby's gale in October of 2002? Now, I just didn't base this just upon that one storm. What I did was I used a computer program and looked at all of the cases where a full moon or a new moon was, number one, at perigee, at its closest point to the Earth, and also passing directly over the equator at the same time. That was a very important parameter because, we have perigee moons, perigee full moons every year. Well, my goodness sake, we had a supermoon this very week. And next month, we're going to have another full moon where it's going to be very close to that perigee point again. And it once again will be called a supermoon in May. But to have that happen when the moon is passing directly over the equator doesn't happen very often. In fact, it happens maybe on the average of once every 20, 30, 40 years. And it was researching this article that I found that in some of those cases, we had some really unusual weather that took place. Take, for example, and by the way, also, To have the full moon or the new moon at perigee over the equator can only happen usually in the fall or the spring, March or April, September or October. And usually around that time, we have, of course, the equinoxes, the vernal equinox in March, the autumnal equinox in September, and sailors who sail the seven seas used to refer to an equinoctial storm, a storm that seemingly, or a line storm, a storm where when the sun was crossing the equator, the line, either north-south or south-north, there always seemed to be within a few days or a week or two of that time frame, some major disturbance, some major storm that caused a lot of damage. So with this particular setup, I did a little bit of research and looked up times when the moon, the new moon or the full moon, was passing over the equator in March or April or September, October. And did it cause any kind of a major problem, a major calamity? I found one case in March of 1967, March 22nd to be exact. This is the official forecast from the United States Weather Bureau. We today call it the National Weather Service. This is the forecast that appeared that day in the New York Times for New York City, mostly cloudy today with a few snow flurries likely, and then clearing this evening or tonight. Highs today in the upper 30s, lows tonight near 30, fair and seasonable tomorrow. Okay, all right. So a few flurries. That's all the forecast was saying for that particular day. Well, guess what? Oh, there was a storm that was passing by that day. On that day when the moon was closest to the Earth, it was at full moon phase then. And what was the ultimate outcome of this? And this again was March 22nd, 1967. What was the outcome of that particular scenario? Oh, surprise! Surprise! Oh, 10 inches of flurries. And those flurries clogged the roads, airlines and buses delayed, precarious walking, high drifts, gusts, bedeviled pedestrians, schools closing early, a spring snowstorm that surprised the metropolitan area. I mean, what happened? Over here, you see a picture of Anthony Tancredo. He was the meteorologist in charge at the Weather Bureau at Rockefeller Center. That was back in the day when they were in Rockefeller Center. The New York City Weather Forecast Office now is on Eastern Long Island. But I love what the newspaper wrote about this. The storm had moved very much as the forecasters had predicted. Normally, a storm like this would give up little or no snow, one meteorologist said, like a man trying to explain to his wife why he hadn't phoned when he missed the train. Anthony Tancredo, the meteorologist in charge, said that he was right only most of the time. He said that the forecast turned out to be like good surgery that didn't turn out well. The operation was successful, but the patient died. And again, the big question is, why did that storm that was predicted suddenly blow up into a major storm that dumped lots of snow on the New York area unexpectedly? That on the same day that the moon was in full phase, closest to the Earth, and moving over the equator. Well, maybe that was just a coincidence. The next time that was going to happen was in March of 1993. Here you see a satellite picture of that particular storm. This storm was labeled the storm of the century. March of 1993. This storm dumped 1 to 2 feet of snow from New England all the way down to Mississippi and Alabama and caused major tornado activity across the Florida Peninsula. This storm also had some of the lowest barometric pressure readings ever recorded for parts of the mid-Atlantic seaboard. This was a major, major storm, March of 1993. And it coincided again with a full moon and a perigee moon and a moon that again was crossing the equator. All of these things that happened, the same thing with Saxby's Gale. Here you see how the New York Times reported that storm. Whoa, storm paralyzes East Coast. Snow covers the South, 33 killed. My goodness, was there something to this? Did Saxby accidentally latch onto something? Is this really a secret way to forecast major storms That's what I asked in that WeatherWise column, that WeatherWise magazine article in October of 2002. So we all sat and we waited for October 5th to come. And I said to myself, my goodness, if there's some kind of a tropical system like in 1869, we may be in trouble. Uh-oh, uh-oh. Well, at the end of September of 2002, we did have a hurricane by the name of Kyle. And that storm was intensifying. Now, it was out to sea. This is taken, the satellite picture was taken. You can see here's Puerto Rico, the Dominican Republic, and Haiti. And the United States eastern seaboard was somewhere up to the north and east. But October 5th was still about 5 days away. Plenty of time for this storm system to maybe take a path similar to Saxby's gale in 1869. Now, if you know anything about hurricanes, you know that classically they move generally on courses like this, either straight out of the Atlantic Ocean and curving up, let's say, toward the Gulf of Mexico, or maybe when they get close to the Atlantic seaboard, they move up and then they usually curve. Usually there's a subtropical high pressure cell here in the central Atlantic, and they curve around the periphery or the back edge of that high pressure cell, and sometimes they curve around to move up along the eastern seaboard. That is the usual course in most cases of a hurricane. Well, you want to see what Kyle did? Was Kyle under the influence of the lunar circumstances that it was? Oh, look at this. Look at this. This was the path that Kyle took. It looked like Kyle was drunk. It made a loop-de-loop here. Then it came down and up, and it kind of wobbled here. And then it made another loop here, and then it went down south and west, and then made west, and then curved along the Atlantic coast. Then it died. I've been forecasting the weather for many, many years, and I've never seen, or rarely have ever seen, a hurricane or a tropical cyclone take a crazy path like this. It was ridiculous, and it also was a very long-lasting storm. It was around for a good something like 21 days, 3 weeks. So whether or not the moon had any influence on the unusual track that was taken by this hurricane, I'll leave it up to you to consider. But a really strange scenario occurring or coinciding with the occurrence of that perigee moon in 2002. Well, maybe it's not just the moon. Remember at the beginning of my talk, I mentioned the Farmer's Almanac and how they say we rely on solar activity. Maybe the sun has a play in forecasting the weather long range or long term. The sun, if you've ever watched it over a long period of time, sometimes it appears blank. Sometimes it appears to have these large spots on its surface. These are sunspots. They are magnetic storms on the surface of the sun, what we call the photosphere. Now, the surface of the sun is 11,000 degrees hot. The sunspots, these storms, these magnetic storms, are much cooler. They're on the order of about 7,000 or 8,000 degrees hot. So that's why we see them as dark spots on the sun's surface, because they're 3,000 or 4,000 degrees cooler. That cooler surface, the cooler of storms, make it appear that they're black or they're dark, but they really aren't. If we were able to lift a sunspot off the surface of the sun and let it shine on its own, it'd be very, very bright indeed, blindingly bright, almost like the sun. But the sunspots, from the sunspots, we get solar activity. We get solar flares. We get what we call prominences, large tongues of hydrogen, which jut out into space. And these solar disturbances spew out from them subatomic particles that are attracted to the Earth's magnetic poles. And sometimes when they slam into the Earth's magnetic poles, they create disturbances which black out radio transmissions, and also sometimes create the beautiful display of aurora borealis or northern lights. So the question is, do these sunspots have anything to do with our weather? Well, one interesting fact, they seem to ebb and flow, come and go. Sunspot cycles appear to have an 11-year cycle. In other words, every 11 years or so, we have a peak of solar activity where the spots seem to proliferate, where they seem to appear quite a bit on the sun's face. And then there is a period where the sunspots ebb and diminish, and then there is a time when there are no sunspots or few sunspots. But then just as quickly, the spot activity increases again, and we have more sunspots. Look at how this cycle goes. Again, on average, every 11 years, we have a period when the sun's activity, the solar activity, is at its peak. And we have been categorizing these or cataloging these in cycles. This was cycle 15 and 16 and 17. Back in the 1950s, we had sunspot cycle 18 and 19. In the early 70s, sunspot cycle 20. And this has continued until the present time. We are now getting ready to move into sunspot cycle number 25. But there is a question as to what is going on with the sunspot cycles, at least of late. This gentleman is Mr. John Eddy. He was a researcher, a solar researcher at NASA. And in the 1970s, in doing research of past sunspot cycles, he came across something very interesting. He came across a period of time in the late 1600s and the 1700s where there were very few, if any, sunspots at all. And in fact, the spot cycles, the ones that had very few sunspots back in the 17th and 18th century, these cycles were first noted by several people. This gentleman who you see here, Maunder, and Mr. Maunder took note of the fact that between 1645 and 1715, there was nary any sunspot activity, no sunspots at all. And because of that, and because of his notation of that, John Eddy in the 1970s, in doing his research, referred to that cycle from 1645 to 1715 as the Maunder minimum. A minimum, well, some minimum, no sunspots for nearly half a century, more than half a century. And then there was another cycle that was noted by this gentleman. His name is Gustav Sporer. And Mr. Sporer pointed out that during the 1300s, there was a similar cycle when there was not much in the way of sunspot activity. How could he make a prediction, or how, not a prediction, but how can he make a case like that? The telescope wasn't invented until 1610, and that's not until after the invention of the telescope did we start noticing sunspots. So how can Mr. Sporer say that there were no sunspots in the 1300s, 300 years before the telescope was invented? He did that because he was also a dendrochronologist. In other words, he looked at tree rings. And apparently, tree rings, when a tree grows a lot during the course of a year, notice how the separation between one ring and another over the course of a year's time is very wide. When there's not much in terms of growth, the rings are closer together. And it was his contention, Mr. Sporer's contention, that during the 1300s, the rings of trees were very close together. In fact, there was not much in the way of growth in trees at all during that time. And then suddenly the rings started to widen again, indicating that perhaps there were warmer temperatures and more significant activity. And he attributed that in part to the lack of sunspots. Yet there was another person who took note of the paucity, the lack of sunspots. That was just who noted that, and he was a meteorologist in England, who noted that between 1790 and 1830, there were no sunspots or hardly any sunspots at all. So these three people, Maunder and Sporer and Dalton, all pointing to periods in the sunspot cycles where there were no sunspots. But what makes all of this interesting is that during those times when there were no sunspots, guess what? It got cold. In the northern hemisphere, the temperatures got abnormally cold. This view taken from sketched or rendered of a lake in Holland, where people during the wintertime were actually able to skate and walk and have winter games on the ice when they normally would not have that ability to do so. We can still see to this very day, every year, an example of possibly the lack of any sunspots leading to cold weather. In the story, A Christmas Carol, that was written by Dickens back in the early 1800s. When you've seen or read this story, what is the image that you see? You see merry old England, but it's cold and it's snow. And if you go to England now during the Christmas season, you're more likely to run into mild temperatures well above freezing. And if it's going to precipitate, it usually precipitates in the form of rain. There really isn't not much in the way of snow around the Christmas holiday season. But back in the early 1800s, this was the thing. When Christmas came at that time of the year, this apparently was what you would normally expect, cold and snow. Was this due to the fact that there was a lack of sunspots, and because of that lack of sunspots, it was unusually cold during that time frame? One Russian, Zarkova, has written a paper, and in that paper he points out the connection between solar activity and climate. In the 1300s, well, look at this. Here's the Sporer minimum. Look at the lack of sunspot activity that occurred during that time frame. And then we had the so-called Little Ice Age from 1645 to 1715, and again in the early 1800s, a combination of the Maunder minimum and the Dalton minimum, the times when sunspot activity was unusually low. Then the sun seemed to come out of it, wake up, and we had the normal sunspot cycle every 11 years. We've had a lot of activity during the 1950s and 60s and 70s. Sunspot activity was unusually high. And we actually had, according to Zarkova, double sunspot peaks during the 70s and into the 80s. But now, take a look. Sunspot activity has now begun to diminish again as we move toward the end of the 20th century and into the 21st century. And he is predicting, Zarkova is, that solar cycle 26, we're moving into solar cycle 25 now, but solar cycle 26, which will be occurring or peaking in the mid 2030s, will be the end of the modern sunspot maximum cycle, and that we will once again go into a period where sunspots will be very few, if not existing at all. And who knows, at least according to Zarkova and other scientists who are saying that we're going to be going into a period of cooling. Maybe global cooling could offset global warming that we have heard so much about in recent years. Here's another proof of the pudding. Take a look at the sunspot cycles, cycle number 21, 22, 23, and the most recent cycle, 24. Do you notice something? Do you notice that at the peak of each cycle, it's a little bit less than the peak of the previous cycle? All of these sunspot maximums are going down, down, down. And who knows, we may have another weak cycle for number 25, which will be peaking in the middle part of this upcoming decade, say around 2024, 2025. And then the last of the significant solar maxima in the 2030s. And then, who knows, maybe a period of several decades or more where we will have very few sunspots, and maybe it will get unusually cold. Well, that's still under contention. There are some who say, yes, that will happen, but there are others who say, no, not really. Does a lack of sunspots mean that it's going to be unusually cold later on in the coming decades? I had an interview on News 12 about 10 years ago with this gentleman. He is a climatologist for NASA at NOAA. His name is Gavin Schmidt, and he has done extensive research into such things as particulates, tiny little particles in the upper atmosphere, which may have some influence on our weather. And when I did the interview with him, I asked him, I said, Dr. Schmidt, is it true that as we see fewer and fewer sunspots, that it's going to turn progressively colder? And Dr. Schmidt was very quick to answer. He said, absolutely not. I said, well, what's the cause? Why did it get so cold back in the 1700s and 1800s? The Little Ice Age. It coincided with sunspot minima. What is, if it's not the sunspots, what possibly could have led to that spell of cold weather? And Dr. Schmidt said, volcanism, volcanoes. During that time frame, during the 17th and 18th century, there was a plethora of volcanic activity all around the world. Volcanoes which sent high into the stratosphere, 10 to 20 miles above the surface of the Earth, dust and ash and gas, these clouds of material that went high into the atmosphere, spread around the northern hemisphere, and helped to not completely block out, but to attenuate, to diminish the amount of sunlight that reached the Earth, thus causing the global temperatures, at least the northern hemisphere, to diminish. Not by much, only a degree or so Celsius, but that was certainly enough to influence the weather, cause the temperatures worldwide, not necessarily worldwide, but again, across much of the northern hemisphere, to fall. In fact, he points out, in 1814, we had one of the greatest eruptions of a volcano that occurred over a span of the last 2,000 years. This was Tambora, which occurred in Indonesia. This volcano sent such a tremendous the atmosphere in 1815 that in 1816, temperatures across the northern hemisphere were well below normal. And in fact, it snowed in New England every month of the year. In June, July, August, September, it snowed. Not a whole heck of a lot, but to see even one snowflake during what is normally the hottest time of the year, July, that's something. And that year, 1816, farmers across much of the northeastern part of the United States were unable to grow much in the way of crops. That was known as the year without a summer. And Dr. Schmidt said, no, forget about the sunspots. Sunspots had nothing to do with this. Sunspots had nothing to do with the little ice age. Sunspots had nothing really to do with it. It was volcanic activity. That's what was the cause. That's what would be the cause again if we saw a sudden increase in volcanic eruptions and activity in the future. So you can see it is a very contentious issue. Very knowledgeable scientists, PhDs, far out of my class, who are fighting with each other in proclaiming what may or may not have caused the lowering of the temperature, or what may cause the lowering of the temperature, both in the past and in the future. So we move on. We've talked about the moon. We talked about the sun. How about the planets? Can the planets have any influence on our weather? Well, some believe that they do have an influence and can be used to make long-term forecasts. But there was one forecast that was absolutely off the wall and occurred back in the early 1980s. Actually, it started in the 1970s. It was a book that came out called The Jupiter Effect: The Planets as Triggers of Devastating Earthquakes. This book was written by two gentlemen, John Gribben and Stephen Plageman, and they even had a foreword done for the book by the famous science fiction writer and science writer Isaac Asimov. According to these two gentlemen, there would be an alignment of the planets in 1982 where all the planets would pull on the sun, causing the sun to cause gigantic solar activity. Solar flares, sunspots would eventually lead to tremendous weather outbreaks of storms on the Earth, and also enough gravitational and tidal influence to cause earthquakes in various locations, most notably in the book, California, for example. California's been waiting for the big quake that would cause all kinds of major destruction. Still waiting. They've had major earthquakes, but nothing quite like what it was indicated in this book. And of course, you write a book like this, and others want, and it was a bestseller. I mean, it sold tremendous numbers. People buying this book to read about Armageddon, and it spawned other books like this book, Earthquake, 1982, by this guy, Doug Clark, When Planets Align. Also, it's referred to when we have planets aligning as a syzygy. So you get all kinds of craziness out there. But can the planets really have an influence on our weather? Well, there are, as I said, some people who believe that. This gentleman is Jim Witt. And those of you who listen to WHUD in the Hudson Valley are well aware of Jim. He's been around for a good long time. In fact, Valentine's Day of next year, Jim is going to be celebrating his 50th anniversary. Amazing run. 50 years on one station, WHUD. You can hear him on Saturday mornings with Mike Bennett on the WHUD morning show, giving his weather forecast. Jim has been putting out a calendar. You know, when Harry Geiss made that amazing prediction about the snowstorm on Christmas in 1966, Jim, who was teaching at Lakeland High School and was actually teaching a course in meteorology for high schoolers, they even had their own weather station. They even had their own teletype. For goodness sake, Jim even was able to get radar for the high school so that the kids in high school were able to learn about meteorology. And in fact, many of the people who are working now at NOAA, at the National Weather Service, were taught by Jim in his class at Lakeland High School. He's a great guy, a great teacher. And so when when Harry Geiss made that amazing long-range prediction, Jim wrote a letter and asked him, "How did you do it?" And Harry Geiss called up Jim Witt and said, "You know, you say you're a teacher, right?" And Jim said, "Yeah." He says, "Well, I'll tell you what. I'm not going to tell the secret of how I did it to anybody, and I'm not going to even tell it to you fully, but I'm going to give you some hints on how I did it. And then you research it and work out your own plan or game plan of long-range projections, long-range forecasts." By the way, Harry Geiss only stayed in New York for 1 year. He eventually said, "I can't take it in New York," and he went back to California. And he is a legend in California. He's kind of like the Frank Field of California. But that left it up to Jim to figure it all out. And Jim in the 1970s started making his own long-range predictions. And people who listened to him on WHUD, Jim said, "If you want to know what I'm calling for this upcoming year, send a self-addressed stamped envelope and I'll send you my long-range forecast for the upcoming year." And the station used to get deluged with requests. People wanted to know what Jim's forecast was for the year forthcoming. Finally, in 1985, they said to him at WHUD, "How about if we made a calendar and you could make your weather predictions in the calendar?" And Jim said, "I got a great idea. How about we make the calendar and we collect the money for the calendar and use it for children's charities?" And Jim came up with a charity called the Hope for Youth Foundation. And he has been head of that foundation since 1986. And he's been selling that calendar since 1986. The Hudson Valley Weather Calendar continues to this very day. And to this point, Jim has made over $4 million. And what has he done with that $4 million? Did he pocket it himself? Did the radio station WHUD take any of it? No. The Hope for Youth Foundation has taken every single cent and has donated it to causes for children who was dealt a bad hand in life. Charities such as St. Jude and Ronald McDonald House and a whole slew of others. I think 30 other charities have gotten that money all from this weather calendar. And it must be very successful for Jim. I mean, if the calendar was, if those forecasts that he's been making all these years were not accurate, why would anybody buy the calendar? But they have. People have been buying this calendar year in and year out. And if you want, maybe he still has a copy available. Go to www.hfyf.org or Google Hope for Youth Foundation calendar, and you can look into maybe purchasing a copy. On the back of the calendar for this upcoming year, Jim has outlined Mother Nature's coming attractions. Look at this. He has done predictions all the way out until the year, 2028. And these are important dates, he says, to watch in the future. Important dates for potential storminess. Here's this year's forecast for 2021. Let me point out to you that he has hit on 3 out of these 4 dates so far. He was able to hit on 3 out of the 4. And in fact, take note of the fact of this: January 28th to 30th, 2021, just 2 days later, we had our big snowstorm, our big blizzard. And there was also, remember, in the middle and latter part of February, around the 19th, there was that one storm where it kept snowing and snowing and snowing, and so it didn't want to stop, it seemed. You'd say, when the heck is this thing going to end so we could finally get done with it? 36 hours of snow. There it was. There was one of his predictions right there. Now, he didn't hit March the 14th to 16th. And I point this out to you now. Maybe you want to make a mental note. May 25th to 27th. Who knows? We may end up with a sharp cold front that may produce thunderstorms or anything. What I'm telling you is that, in 2 out of 3 cases, in all of his cases, Jim pretty much nails it in terms of potential storms. So we'll see what happens when we get to the middle or latter part of May, whether or not this forecast comes out all right. But Jim has been doing these long range forecasts, and he says that it's the planets, the sun, the moon, and he uses the planets. He tells me sometimes, he said, Mercury is in retrograde. You say to yourself, how is that possible? I've said to him, Jim, Mercury is the smallest planet. How could it possibly have any kind of influence on our weather? And for the longest time, I said, it's crazy if anybody could think that the planets could have any kind of influence on our weather. Well, you know what? Just a year or two ago, a very prominent meteorologist and climatologist at the Lament Earth Observatory, Columbia University, Dennis Kent, did some research and came up with this conclusion in a very interesting technical paper. He writes, Jupiter and Venus are such strong influences on the Earth because of their size and proximity to us. Venus is the nearest planet to us and roughly similar in mass. Jupiter is much farther away, but it is the solar system's largest planet. According to Dennis Kent, every 405,000 years, again, another cycle, due to wobbles in our Earth caused by the gravitational pulls of these 2 planets, seasonal differences here on the Earth become more intense. Summers are hotter, winters are colder, dry times drier, wet times wetter. So yes, the planets do have an influence on our weather in small range cases, and in this case, 405,000 years, long range cases as well. I wouldn't have believed that, but here we have somebody from the very, very distinguished Lamont Earth Observatory, Columbia University. That's up in the Palisades here in the Hudson Valley, who points this out. So yeah, maybe there is something to this. But again, contentiousness. There are going to be scientists who say no. There are scientists who say yes. The question about long-range predictions using the sun, the moon, the planets, yeah, well, some say that there's something to it. Others say no. Like, for example, Dr. Schmidt. We'll just have to wait, watch, and see. But in any case, I think a very interesting subject, the science or pseudoscience of astrometeorology. So I want to leave all of you with this. I was a weather forecaster on radio and television for a good number of years. I always, as I said, tried to get it right as best I could. Here is a gentleman who, in his own profession, was probably as good as anybody. You may recognize him, especially if you're a Met fan. The name Bill Buckner. Bill Buckner played for several Major League Baseball teams, including the Red Sox. He was a highly regarded. I want to tell you something. Bill Buckner came this close to being in the Hall of Fame. In his career, he had 2,800 hits. He was a batting champion for 3 years. He was also very renowned for his fielding. He was an excellent fielder. Let me tell you that if you were a baseball manager in the 70s and the 80s, and the name Bill Buckner came up, you said, I want him to be on my team. He was the consummate professional in baseball. Yet, sadly, and Mr. Buckner passed away a couple of years ago. Sadly, what is Mr. Buckner always going to be remembered for? He's going to be remembered for this, that little ground ball that went up the first base line in Game 6 of the World Series that went through his legs, allowing Mookie Wilson to drive in the winning run, allowing the Mets to tie the World Series at 3 games apiece. And the next night, of course, the Mets won the World Championship, and everybody blamed, and this really is not really fair, everybody blamed Bill Buckner for it. I mean, there were a number of different circumstances that caused the Red Sox to lose that night, but everybody puts the blame on Bill Buckner. Again, a consummate ball player, but one mistake, and he was tagged for life as, Bill Buckner. They even used to laugh at him, but he was a great ball player. But sadly, he was remembered only for a mistake. Nothing about his whole career, just one mistake. And that, ladies and gentlemen, is what I call the weatherman's lament. Because, weathermen, most good forecasters are right 9 times out of 10. But here is life's great December. Those in the main are our regrets, because we, weather forecasters, when we're right, nobody seems to remember. But when we're wrong, like Bill Buckner, no one forgets. And I want to thank all of you for listening to me talk for the past hour, a little over an hour or so, about the connection or possible connection with meteorology, with science, with the events of whether or not the sun, the moon, and the planets have anything to say or anything to do with our weather and weather forecasts and long-range forecasts. So again, I want to thank all of you for listening, and I guess if you have any questions, I'll be very, very happy to answer them or try to answer them. Back to you.
Yeah. I do have one question from an audience member here, Joe. When is the next Perigre full moon that will cross the equator?
You know, I tried looking into that, and I stopped looking after about the year 2040. It probably is going to be sometime in the middle part of this century. But you know, doing the even with a computer, doing the calculations over year by year by year takes a rather long time. I assure you, it's not going to happen this decade, 2020, not in the 2030s. I stopped when I reached 2040, and I said, well, whenever it's going to happen, it's going to happen. Who knows? I may not be here. Maybe a lot of you won't be here. But when I'll tell you what, when I do find out, when I do figure it out, I'll post it on my Facebook page, and I'll let all of you know. But I had to figure that somebody was going to ask that question, but again, it's going to be a while off. It's going to be a long ways in the future.
Okay. If anybody has any questions, feel free to turn your camera on, unmute yourselves. Go ahead and ask away if you'd like.
Anybody?
Does anybody have any questions?
Hello. Maybe if you're muted, unmute yourself, and you could just ask your question, or if
in the chat. Sorry. Oh, I just had a quick one. When you briefly mentioned before, you were talking about the Jupiter and Venus thing about Mercury being in retrograde, and I had heard that was something that was happening this year, and didn't know about it until it was basically at the end of it, and then was told that all these other people were really obsessed with how Mercury was in retrograde. So I don't know if you could talk a little bit more about that.
I know that the astrologers like to say that when Mercury is in retrograde, that it's a period of bad times ahead. And quite honestly, I don't know how Jim Witt uses the planets, but I was trying to use an example as to when the planet is in a certain circumstance or whatever, and how it might have an influence on the weather. And the only thing I could think of was what the astrologers say: Mercury in retrograde. That may not have a play or say in the weather specifically. I was just using that as like an example. But I mean, when the planets, I guess, are in a certain position, they apparently may have an influence on the weather in producing possible, storminess or frontal passages or whatever. Again, I don't do long-range forecast, and I don't know how quite Jim or Harry Geiss did it, but I was just using that as an example. But yeah, I've heard that supposedly when Mercury is in retrograde, that the people who write up the horoscope say, basically, make sure that you're protected because it's a bad time for you. I personally don't believe it. I'm not into astrology. As I said, I'm very heavily into astronomy, and every once in a while, somebody will walk up to me and say, "Could you give me a reading? Can you tell me what's going to happen? Because you are into astrology." I said, "No, I'm into astronomy. Astrology is a pseudoscience. Astronomy is a true and genuine science." But whatever floats your boat. I do notice this: 99% of all newspapers have a horoscope or an astrology section every day that people consult to find out, I guess, what's going to happen to them or what's going to occur. You look at the horoscope and you say, "Let me see a horoscope for today for my Leo." a great day to ask for a raise. Yeah, if I had a job, I would ask for a raise. But, I notice it's all astrology. Very few newspapers have an astrology, which would tell you where the planets, where the moon is going to be at a certain time of the night, or whether an eclipse is coming up. That's something of interest, I think, to a lot of people, not these projections or predictions to what's going to happen, in your future based upon the movement of the planets. And again, that's how some meteorologists and climatologists look upon long-range forecasting, the Farmer's Almanac, the old Farmer's Almanac. Don't those things, to tell what it's going to be, like, 6 months or a year down the road. But people buy the almanac because, just like astrology and horoscopes, some people believe in them too.
Thank you.
Does anybody else have any other questions?
Very interesting talk. Super, I really enjoyed it.
Well, thank you. Thank you so much. That's
So
what we're here for.
You mentioned some of the things that you're doing. You said the Joe and Joe show. How can people catch that?
Oh yes, well, if you're into meteorology, if you're into weather, we'd like you to join us. I do a show on YouTube every weeknight, well, most every weeknight, with my cohort Joe Chiaffi. Some of you may remember Joe. He was on Pix 11 doing the weather, and he was also on News 12 from time to time. Joe and I, we do what we call the Joe Weather Show on Joe's YouTube channel. Joe has a YouTube channel, Joe Chiaffi, on YouTube, and most nights at 7:30 we do a show. It usually runs about an hour, where we talk about the weather for the upcoming next few days. We didn't have a show tonight because I was doing this. We'll take tomorrow night off as well. We also have a show on Sunday morning. We call it Coffee with Joe and Joe at 11 a.m. on Sunday morning. And we get together. We have a nice tight group. We've had anywhere from as few as 50 to as many as several hundred people. When the weather gets really active, we get a lot of people tuning in to us on YouTube. So if you're not doing anything most nights, tune in on Joe Chiaffi's YouTube channel. Again, we usually sign on most weeknights at 7:30, and if not, Sunday mornings at 11 a.m. Again on Joe Chiaffi's YouTube channel. And along with that, I'm on Facebook. I have a Facebook page, and I often put weather forecasts up, and also talk about other interesting things regarding astronomy, meteorology, and physical science. And also, I'm doing library talks. I'm doing not just here at this library, but also at other libraries around not only Hudson Valley, but around the tri-state area. I'll be giving a talk soon about the eclipse. I don't know if any of you are aware of this. There's going to be an eclipse of the sun on Thursday morning, June the 10th. Set your alarm clock. Sunrise is at 5:30 that morning, but it's not going to be anything like any sunrise you've ever seen in your life. The sun's going to rise that morning, 80% eclipsed. It's going to rise looking like, well, a cantaloupe slice, like a crescent moon, something that has happened only twice before in the New York area, in 1875 and in 1959. So we're going to get a chance to see a really a once-in-a-lifetime solar eclipse here in the New York area coming up that morning. Sunrise is at 5:30 a.m. So tune in on my Facebook channel if you want. You stay on top of that, with the Joe and Joe
Excuse
show on
me.
YouTube.
What
Yes,
day
ma'am.
did you say? What day of June? June 3rd?
Thursday morning, June the 10th.
Oh, June the 10th. Okay.
June the 10th. And Katie, to everyone, I seem to remember many solar eclipses in the 70s. Is my memory accurate? Yeah, New York had an eclipse that was almost total in 1970, in March of 1970. And we also had partial solar eclipses in 1973, 1977, and again in 1979. So you're right, an eclipse of sun not unusual in itself. They happen every few years. And you could have in New York, for example, there was a partial eclipse in 1977. What's so exciting about that? The eclipse on June 10th. I mean, the sun comes up that morning. I mean, the sun comes up like a big red ball, you know, or go down as like a big red ball. So that will be something real special to see, and hopefully all of us will have a chance to see it. Hopefully it will not rain. It will be cloudy on that particular morning. That will be a bit of a disappointment. Then we'll have to wait for the next total eclipse in New York. I want all of you take note of the next total eclipse. May the 1st, 2007. So stick to your vitamins and do a lot of good wishing, but so it goes.
Does anybody else have any other questions, comments, anything?
Somebody on the chat board said it's amazing that I know off the top of my head these eclipses, and that's because I'm what you would call an eclipse chaser. I chase you've heard about people who chase tornadoes and chase hurricanes and thunderstorms. I don't do that because, well, I want to still live a few more years. It's a little dangerous to chase a tornado. However, chasing an eclipse, and that is a bucket list event. That is one of the great sights in your lifetime. If you ever have a chance to see a total eclipse of the sun, once you see your first, the first thing out of your mouth after you see it is, when can I see another one like this? And I have traveled around the world. My last eclipse was the Great American Eclipse of 2017. That was my 12th eclipse. And I'm hoping to see my 13th in 2024, when we'll have a total eclipse across New York State, Buffalo, Rochester, Syracuse, Plattsburgh, all of the states, state New York will see a total eclipse on that day, April the 8th, 2024. And hopefully it will be clear on that day as well. If you say to yourself, I'm not going to travel, I'm going to stay right here and wait for a total eclipse to come to me in 60 years. The long time between total eclipses. Wait for just a few hours. Take advantage of that. And if not, wait until 20. I'll do my best.
Well, if nobody else has any questions, excuse me, where did you see the last one, the one in 2017?
I was on board a plane.
Cool.
I'm crazy. All right. I will do anything to see a total eclipse of the sun. In 2016, I contacted Alaska Airlines because I had seen that the path of an eclipse of the sun, total eclipse, was going to happen between Hawaii and Alaska. And I noticed that they had a flight from Anchorage, Alaska to Honolulu. And I said to them, if you were to delay that flight by a half an hour, if you were to hold it up for just a half an hour and just run your regular route, then along the track that you normally would take on that flight, you will run right into that solar eclipse, and everybody on board will have a chance to see one of nature's great spectacles. They apparently listened to me. Well, they did. They changed the flight path a little bit. They delayed the flight by a half an hour, and everybody on board that flight got a chance to see the total eclipse of the sun. And it was so successful. They had a camera crew from, I believe, ABC on board that flight. It was so successful that when the Great American Eclipse came up in 2017, they called me and they said, can you help us? We'd like to do it again for the Great American Eclipse. And I said, sure, I'd be happy to. And the nice part about that was that I was able to bring my wife along with me and my 2 children and a whole bunch of my friends too. They said, yeah, come on board. We'd be happy to have you. And also they had news media from all over the world, not just the United States, but Canada, the BBC in London, everybody, the Weather Channel. We were all on board that flight, and we all had a chance to look out and see that total eclipse from 35,000 feet over the Pacific Ocean. It was fantastic. And the last thing I said to the people at Alaska Airlines is, hey, by the way, there's going to be a total eclipse over Alaska in 2033. So if you're interested, you might want to do that again. He said, and the head of Alaska Airlines said to me, he said, it's a date. So who knows, in 2033, maybe an airline in Alaska Airlines.
Very cool. Well, does anybody else have any last questions? Or
Just a quick one. I was wondering if you have any other like book recommendations on these topics, or like other meteorology topics.
Well, I'm doing. I mean, tonight we cover meteorology. I also do a talk. I provided Katie with the program prospectus that I'm doing, and I do a talk. What you for that gets the forecast from. Having done that before, I talk on that. And I also have a called The Science of Snow. I don't have the book, unfortunately, with me, but I wrote a book for Simon & Schuster for grades 2 to 4. Snow enjoy the book and would enjoy the factoids that are provided about where snow comes from, how do they form, the biggest snowflake, the heavy. So I did a whole program in the year when it gets cold again. Maybe we'll do a show about snow for youngsters. So there are all kinds of topics. As a meteorologist and an astronomer, I've got a whole bunch of things I can talk about in terms of both weather and astronomy. And I'm really enjoying myself going to libraries and giving these presentations and interacting with all of you and taking questions from all of you about these 2 topics, which I've always enjoyed. And I'm having a ball. I hope all of you have a ball tonight. And maybe I'll be back here at the Scarsdale Library sometime down the road.
I sure hope so, Joe. Thank you so much for all of this. This has really been great.
Well, thank you. Thank you so much. And if that's so,